All right, so this is for question number 2, multiple choice question number 2 on the Unit 8 for AP Classroom Review. This one's about the gray wolves in the Yellowstone National Park. And in this question, the student says that the carrying capacity is 100 wolves, and the R max, which is the growth rate, is 0.6 per capita, which is like per wolf, so it's kind of by the population. Um, and so when we're calculating
Keys
this,
for dismissal. Kylie Keys for dismissal.
we're going to use the equation for logistic growth rate. So if they don't give you a carrying capacity, you're assuming that there is no carrying capacity, then you can use the exponential growth rate. But as soon as they introduce carrying capacity, even mentioning it, you know you have to do the logistic growth rate, because now it's going to be limited by resources, which is how it actually is in real life. So in this case, we're going to have our change, all right, which is what we're going to calculate, all right. Then we have our R max, which is 0.6, is what they told us, okay. We have our current population. So this is the tricky thing, is that when they're talking about current population, they're not talking about like the original population. They're talking about whatever it is most recently when you're comparing it to, calculating for the next generation. So we have to look, and it told us that in 2016, it was 108 wolves. And now we're calculating for 2017. So we have to look at that 108. Okay. And then we have the big set right here. And this was K minus N all over K. K is your carrying capacity. So we have 100 minus 108 all over 100. All right? So if you calculate this out, what you're going to end up with, and I'm doing this kind of from memory, is that your change is going to be -5 and then a little bit. But you're not going to have and then a little bit of wolf unless something terrible happened to that wolf. So roughly -5. So if you take that change of the -5 and then add that change to the 108, which is your 2016 population, you're going to have 108 minus 5. So if this was a positive number, it would be 108 plus whatever the number is. It's negative, right? So it's 108 minus 5 equals 103. So if that student is correct in the R max value and the carrying capacity, then we actually expect a dip in the wolf population to head back towards that carrying capacity. And this makes sense. So if we have a population, we have our carrying capacity, we're going to kind of go up over it, then we're going to kind of go down under it, and it's going to be kind of like that. So that's what we expect to see. And this is saying that now we're on that downward trend back towards the carrying capacity. Most likely the next year or two, we're going to drop below the 100. Then we're going to slowly come back up to the 100 and over it. And it'll just keep kind of going in a nice, easy wave. So I am going to post a video on Google Classroom. I'm going to post this one. I'm going to post another one where it's just talking about the 3 equations in general about the populations. Definitely watch it. It's not that long. The one that filmed it did a great job explaining the 3 different graphs that you could use, or 3 different equations that you could use. Make sure you pause as she asks questions, like she'll give you scenarios. Pause it, try to calculate yourself, and then compare that to what she shows in the video. That's really a good exercise to do. And then I'm also going to post a video just on the wolves of Yellowstone. It's a really cool video. It's like 4 or 5 minutes long, something like that. Some of you may have seen it already. I used to show it in 8th grade and sometimes in 10th. Littleton may have shown it in APES. So if you've seen it already, you don't need to watch it again. If you haven't seen it, take the time to watch it. It's worth seeing. All right? Keep the questions coming.